Hello everyone, I'm Amazing. Well, today's tutorial is an advanced Bifrost scattering tutorial. So for this session, which is our very first lesson, we'll just take a simple introductory walkthrough. Now, if we intend to use Bifrost, the first thing we need to do is open up our window. Then, in the plugin manager, search for Bifrost. Make sure to check all of these boxes, and then we'll see this row of windows appear. But then, opening this row of windows, you'll find a Bifrost group compiler. So let's first explain why we use Bifrost for scattering and why not Mesh. Compared to Mesh, our Bifrost's advantages focus more on customization and efficiency. These points completely outperform Mesh because it hasn't been updated for a long time. And Bifrost, we continuously update it. It can also simulate smoke particles, fluids, and so on, as well as composite materials. So what we're going to discuss today is a tutorial on how to walk. Okay, let's open up my personal layout. I'm quite fond of this particular layout, and this window is rather large. Next, we'll first create a group. We can go ahead and delete both of these. These are all elements or nodes that don't necessarily need to exist here. First, we'll begin by creating a plane. We'll use this plane to clone a mountain, shaping it into a mountain. Then we'll remove the mesh from the very center. We can make the whole thing a little bit larger, and then on this mesh, we'll add 300 by 300 subdivisions. Next, we'll take this plane and drag it directly into a compiler node within our Bifrost graph. And at that moment, we will then be referencing a specific plane right here in this setup. Oh, right, my Bifrost version is the very latest, 2.13.0. You should remember this version number, as updating to the newest is quite good. Then we can connect a specific node, which is called displace LSTU point. This displace point node allows us to take our forehead's flat surface and introduce various forms of displacement, creating a textured, uneven appearance. Let's first hide this grid. We're here, and we'll create a new node right here. Well, this node is the same as the out node, but this node will have many more options. So what about this node? Let's talk about what this node actually is. Then we click on this Bifrost group, and then we click right here, and then we'll find that these two match up. The first one is our final render output, the second one is our proxy, and the third one is our diagnostic mode. The general diagnostic mode and proxy are displayed in the window. Then the first one is what we render. Then we connect to our diagnostic mode. You see our Bifrost also outputs our plane. Then we displace it using a noise. We use this. We can connect to this strength, to this intensity. We can see that we already have many bumpy effects on its surface. And this is a scalar field. We'll explain what this scalar field means later on. For now, we don't need to worry about it. We just need to know that we can make it bumpy for now, and then we'll just reduce it a little bit. Don't make it so big, then we'll add a bit more intensity. Okay, our mountain has come out like this, and now we need to scatter our points. What do we use to scatter them? Using a scale out 2 point, and then we connect it to our diagnostic mode. We've noticed that our mountain has disappeared, but we've actually cloned a lot of points. I'm not entirely sure if everyone can clearly see them right now, so we can utilize a specific node to help us visualize these points. It's called the point node. Yes, we can definitely use this particular node to make our points visible. We can make it a bit larger. I just see its dot. Okay. We can change its color to white, change this color property to white, not using this weight, not using this attribute to control it. Alright, so now we're going to import an object that we really like. Okay, we like this grass here. Let's go ahead and import this grass, and then we'll also bring in some bricks. We'll import some bricks and then some more bricks. Okay, for this demonstration, we'll just delete a video. We won't import too many. For example, these three. Then we'll group them. This default group will name it scale out geometry. Okay, then we'll hide them, and just like before, we'll drag them in, drag it in. So, how exactly do we go about cloning this? We have a specific node here. It's called set instance geometry. I found it. Yes, I found this one. It's called LL. Let's do it. It's called set instance geometry. And then our point output, we're going to connect that to this, our scatter node's instance input. And then our actual instance geometry, we're going to connect that directly to these objects right here. So we'll just click right here and then click over here and connect everything up. Then we output to our proxy. Oh, we found our objects were cloned like this, all cloned at this point. So this point doesn't need to be displayed. We can turn it off. Now, there's a problem. I'm not sure if you've all noticed, but we currently only have a single mesh 1 option, missing our bricks and also another plant. What exactly is happening here? Well, that's because every single import has its own unique ID. We need to perform an averaging process to ensure they all possess one. So we'll need to choose a specific node called RAM. So now we'll use this node here. Then we connect the point and then connect our output. And then here we'll just enable it once more. I found that we can control its quantity through this weight ratio, and now we've successfully cloned everything out. And everyone, please pay attention to one issue. If we render this directly right now, we'll be able to see it's going to have a very big problem, which is that each one will inflate just like a ball. We can then create a dome light, and everyone, please don't type it incorrectly because this one is not rendered. It's actually a proxy, and we need to output it to this specific location. Let's have it load the texture set. Okay, it's all completed now, so we can proceed to shut down this construction operation. I can see us quickly clone some grass. Everyone still needs to be aware of this, even though we've scaled it up. There won't be a displacement issue, but everyone should still turn off the displacement for this material. That would be better. Well, just a moment. Not this one. Let's try to open up the toolbar. Hey, how did it suddenly turn out like this? Oh my goodness. Is this what's supposed to be our status bar that's open? Why is this status bar looking so strange? So good, so good. Let's open up our character panel here, and then we'll click on its material. Let's grab its material and then select both of them. After that, we'll just turn off its displacement. There's no real need for it, and this way they'll still render perfectly fine. If we make it too small, it will expand, so now we won't have this problem. We can render it very quickly. So now we have a problem. If we display it like this here and the quantity gets too high, we'll experience lag. For example, if we have 10,000, it might lag a bit. Oh, it's fine, no lag, right? No lag. But 10,000, that's where it gets a bit laggy. So why is that? Because if all our instances are instantiated here, we will experience significant lag. We can make it so that a single block replaces them. We can create a mesh, a cube, and the cube will use a square block to substitute for it. There's a pivot point here. Let's connect it to this location. Okay, we'll now use our small squares to replace it, and our window is extremely smooth and fluid. Okay, let's set it back to 10,000. For our render speed, we'll set it to 10,000. Alright, let's open the render again and put it over here. We'll notice that our grass is all very big. Oh my gosh, and there's no randomness either. So how do we make it random? We can first stretch this out a little, then we add a pass node and we can place it here for now. This pass node is just like Houdini's null node. It doesn't really serve any purpose. It's just like an intermediate node, allowing it to output many different ports. Then if this is modified, everything here will change. For example, right here, this is also output here. And if we were to change a port, all of this would have to change. So there's a pass is quite useless. There's just one thing. We have a feature here, something like this. Then we need to add a round, or rather a roundness property. And over here, there's rotation. Oh, I mispronounced rotation. So we click on this, and then we click on this. We can make our block bigger, just a little bit bigger. We can make it 10 by 10 by 10. 10 by 10 by 10. Okay, we can now see that it has a random rotation. Let me just drag this over a little bit. A random rotation here. We can set its randomness up to 180 degrees, and that will make it much better. Then we'll make its size have a random change. Within our Bifrost scale pack, it actually contains all of the various scattering tools that you might need. We're currently utilizing this, which is set to Z. There's also a point scale that we're working with, and we've also made sure to connect it up. We'll ensure its maximum value does not exceed, does not go beyond 1. And then for our mean, the absolute minimum value can be adjusted to be slightly smaller. After that, when we render once more, we will then observe that there's both rotation and also scaling happening. All right, that looks perfectly fine. Now, everyone will probably notice a problem, which is, hey, why isn't our ground rendering? Our ground also needs to be outputted to our this specific port here. We can now render the ground. Of course, you can also do it this way. Create an out here, or this node, and connect it like this. That's also fine. This way we can quickly render it out. Then we can increase its multiplier. 50k. No problem at all. Our Arnold also had no problem. It rendered directly, very smooth. Alright, so that's pretty much it for this video. Later on we'll be diving into more advanced techniques and uses, but this here is just the most fundamental way to use Bifrost. Alright, that's all for this video. Alright everyone, bye bye.